So, have you ever wanted to solve a really tricky problem by just describing what the answer should look like, instead of, writing out every single tiny step to get there? Well, that's the whole idea behind a pretty fascinating programming language called Prolog. And trust me, it's not just another tool, it's a completely different way to think about problem solving.
You've probably heard this classic programmer joke before, right? And if you're anything like me, the first time I heard it, you were probably thinking, what does that even mean? But I promise you, by the end of this explainer, that joke is not only going to make perfect sense, but just totally get the powerful idea behind it.
See, the key to getting Prolog is you have to do a little mental reset. And the source material points out something really interesting. People who are brand new to coding often find Prolog more natural than seasoned programmers. And why is that? Because the experienced folks have to unlearn that habit of telling the computer exactly what to do step by step.
Okay, so what does this new way of thinking actually look like? Well, it's a paradigm called logic programming, and it's the absolute core of Prolog. It's an approach that completely flips the script on the relationship between you and the computer.
Think about it like this. With a language like Python or Java, you're basically giving the computer a detailed recipe. You say first, do this, then mix these ingredients, then bake for exactly this long. It's all about the how. But with Prolog, you're just describing the finished cake. You say, I want a solution that has these properties and follows these rules. And then you let Prolog figure out how to bake it.
So the big question is, how on earth does it do that? I mean, if you're not telling it the steps, how does it find an answer? It feels like magic for sure, but it's actually driven by three incredibly powerful and pretty unique features all working together under the hood.
And these are Prolog's three superpowers: unification, backtracking, and inference. Together, they're the engine that makes this whole declarative style of programming possible. So let's break down what each one of these actually does.
First up is unification. Now, in most languages, the equals sign means take this value and assign it to this variable. Forget that. In Prolog, it's more like a puzzle piece. Unification is all about powerful pattern matching. If you ask, what's the capital of France? Unification will try to match a pattern like capital France X with a fact it already knows, maybe capital France Paris. It sees the pattern fits, and boom, it binds the variable X to Paris. It's all about making two things identical by just filling in the blanks. Next up is backtracking. This is Prolog's built-in undo and let's try that again feature. So if it goes down one path trying to solve your problem and hits a dead end, it doesn't just crash or give up. Nope, it automatically goes back to the last place it made a choice and just tries a different option. And the best part? You don't have to code any of this logic. It just happens. It's magic. And finally, we have inference, which the source material calls sorcery. And honestly, that's a pretty good word for it. This is Prolog's ability to connect the dots. So if you tell it Socrates is a human, and you also tell it all humans are mortal, you can then ask, is Socrates mortal? And Prolog uses inference to figure out, yep, he is, even though you never explicitly stated that fact. It's literally creating new knowledge from the rules you gave it.
Okay, so with those superpowers in mind, let's look at how you actually build a Prolog program. You're not writing functions or classes or methods. Instead, you build what's called a knowledge base, and you do it using three really simple things.
These are the three building blocks. That's it. First, you have facts. These are just simple, true statements about your world. Things like mail Bob. Done. It's a fact. Then you have rules. These define relationships so Prolog can infer new things. For example, parent x, y, semicolon, father x, y. All that means is x is a parent of y if x is the father of y. Simple. And finally, you've got queries. These are just the questions you ask your knowledge base, like question mark, mail Bob.
And this is the really crucial point. Your whole program is just a collection of these facts and rules. That's your job, to describe the world. Then you interact with it by just asking questions. You're basically interrogating this little expert system that you've built.
Getting good at Prolog really means learning to trust its engine. It's all about letting go of that need to control every little step, and instead embracing this more descriptive, kind of elegant style of solving problems, especially when it comes to something as basic as checking if two things are equal.
Okay, check this out. Here are two ways to see if two things are equal. On the left, that's how an imperative programmer might think. You make a rule called equal 1, it takes two variables, x and y, and then you explicitly check if x equals y. It works, but it's redundant. Now look at the Prolog way on the right. It is so much more elegant. You just defined a fact equal to XX. See what's happening? By using the same variable in both spots, you're not checking for equality, you're describing it. This statement is only true if the two things you give it are already the same. Unification does all the heavy lifting for you, totally behind the scenes.
And this isn't just about style points. As the source material says, this is about leveraging the core power of the language itself. You're not telling Prolog how to check for equality. You're defining what equality is. And that, right there, is the mental leap you have to make.
So why does any of this matter? I mean, is this just some weird academic exercise? No, absolutely not. This whole declarative way of doing things has some really powerful applications. And maybe even more importantly, it actually changes how you think about problems.
Prolog really shines in these super complex areas where you have to reason about all sorts of relationships and constraints. It's used in AI for planning, in logistics for crazy complex scheduling problems, in database work, and even for system configuration. This is a serious tool for seriously tough problems. But maybe the most important takeaway is this quote from one of Prolog's pioneers, David H.D. Warren. Learning Prolog isn't just about adding another language to your LinkedIn profile. It's about getting a new tool for thinking. It forces you to boil a problem down to its essentials, and that makes you a better, clearer thinker, even when you go back to writing Python or Java. And that brings us right back to our light bulb. How many Prolog programmers does it take? That whole question, that's a query. Prolog doesn't care about the number. Its job isn't to give you a step-by-step instruction manual. Its job is just to figure out if the goal, changing the light bulb, is achievable based on the facts and rules it knows. Can a solution be found? Can this be proven true? If so, the answer is just yes. So here's something to think about. The next time you're staring down a really complex problem, ask yourself this. What problem could I solve if I stopped trying to write the step-by-step instructions and just focused on perfectly describing what the solution looks like? That's the power of thinking in Prolog.